Hey friends, in this video we're going to quickly touch on some of the science behind pulleys. And really, we're just going to do a few examples of one simple equation, and it is work equals force times distance. If you've done some other projects with us before, then you know that we've talked about force before, which is essentially just a push or a pull on something. But the difference with work is when what you are pushing or pulling actually moves. And obviously, the distance part of that equation is how far something actually does move. We're going to have to measure that in order to properly calculate the work. Anyways, we think this is best when we actually show you an example. Remember, pulleys work by pulling one side of the rope a certain distance, and what happens on the other side? Well, it lifts or moves the object that's on the other end of that rope. In this example, we move the hand 1 meter down with a force of 60 newtons in order to pull up that weight on the other end. The total work came out to be 60 newton meters, and keep that number in mind for these future examples. So that's all good stuff, but remember in the last video we mentioned that pulleys are actually used in systems. Let's see what happens when we add 2 more pulleys to that one and make it 3 of them. Do you see the 2 extra pulleys in this system? The purpose there is to have more rope that wraps around all these pulleys. Notice the white dots around the yellow rope? Notice the difference between this system and the first one with just 1 pulley. But anyways, check out this quick calculation which shows just how important that distance is. Do you notice how we still arrived at the same number of 60 newton meters of work, but this time it only took 20 newtons of force to move the object since it was covering 3 meters of distance. So all of that goes to show us that you can play with those force and distance numbers, and as one goes up, the other one goes down. So now that you've seen how it works with 1 and 3 pulleys, can you quickly pause this video and brainstorm amongst your friends and neighbors? How do you think adding 2 more pulleys for 5 in total will impact the numbers and the system? So just in case you had a hard time visualizing, here's what a 5 pulley system looks like. As you can probably see, there is a lot more rope and hence a bigger distance that needs to be moved. And as you saw earlier, when we are willing to move over a longer distance, the force needed to make that move becomes much less. You will be able to feel this for yourself soon when we make our own project. But for now, check out this calculation. Again, we end up with 60 newton meters of total work, but this time there's that longer distance, and now it only took 12 newtons of force to lift the same object that took 60 newtons of force with 1 pulley. And when you do take advantage of systems like pulleys or other machines that help reduce the force needed to push, pull, lift, or really move anything, that's called mechanical advantage, which, as I'm sure you can imagine, engineers love playing with, because who would rather work harder to push or move something rather than take advantage of those systems and do it nice and easily? But anyways, we will see you in the next video where we're going to show you how to build your own pulley system and apply what we just learned in this video.